Thanks everybody for coming to the event. Thanks to the sponsors. My name is Richard. I work for AWS. Assuming most people know Amazon Web Services, a little company out of Seattle. And specifically, I work for AWS Mobile and was part of the teams that launched. I launched both AWS AppSync, which is a managed GraphQL service, real-time and offline data, as well as AWS Amplify. I actually wrote some of the first codes and prototype in Amplify. And I kind of lead engineering across that team right now on strategy and direction. And this is a new talk for me, so we'll see how it goes. It's kind of an interesting topic as you kind of look at the news and people are building apps nowadays, and talking about like what the requirements are for securing data. And I'm going to start this talk with I see like an interesting trend on Twitter very often recently, which is a good trend. It's about like interviews and like what knowledge is required to get into programming. And it's interesting because usually people talk about, oh, all of these things like big O notation or knowing all these algorithms, they're not the real world of when you're programming. And then I see sometimes the joke is like programming something's easy like just doing authorization and throwing like a token into a header. And while I understand the point that they're trying to make in those tweets, it's very true about what you do day to day, I will make the assertion that authn and auth or authentication and authorization are not that easy either. And so what this talk is about, as I mentioned, I work for AWS as part of the Amplify team. This is basically a how it works talk, where I kind of want to educate everyone about what happens underneath the covers, the state of the industry when it comes to these techniques and how they work. I'm going to mention AWS-specific technologies through this, but I'm trying to do it in an abstract way so that you can see how the standards and protocols work and kind of what you would need to do if you did some of these things yourself. All right? So with that being said, suppose you're building an app today. This could be a brownfield app at a major company that you want to add more stringent security requirements for. This could be for a consultancy or something else. And you start looking at what you need to do, right? And before I started a couple of these services and worked on these teams, I actually worked in the field as a mobile engineer for AWS. And even like 3-4 years ago, we did not have the P0 requirements that everyone has in the industry today. Like everybody has basic things, right? You need to have registration, you need to have sign on, sign up, sign in, you need to have sign out, you need to have custom attributes, and then people come up with use cases. Well, I need attributes to have certain filtering on them at runtime. I need, different types of MFA from phone to email, and then people bring up issues with some of those, which do exist. And you need N-factor MFA and CAPTCHAs and stuff like that. Then you need social sign-in, this whole topic of federation, whether it's log on with Amazon or Google or Facebook. And once you go down this rat hole, you start to get kind of slammed in the face with a whole bunch of industry standards that everyone wants to do. From OAuth to OIDC to SRP I'll talk about, signing mechanisms, protection techniques like PXE I'll go into. And this is even before looking at your application design around UX, right? So obviously you have certain things like accessibility and what you want to present to your customers. But some of these techniques, you'll do them and get them nailed in the web, and then you'll see how they break down in either the native platforms or even the platforms like React Native, seeing as how we're at React Europe, and I'll talk about that. And as you go through this, I'm not even near done yet on what requirements your customers will come up with. So they'll want some things like public access to where people can read and get access to a website, but before they comment it on an item or download video, they have to sign in, right? So you need to kind of have transitioning of identities. And people then will phrase that, well, I need anonymous access for this use case, and then you kind of get into debates on, does anonymous access even exist on the internet anymore, right? And then even when you start looking at the data itself, you have a myriad of controls from only the people that created certain items in a database can edit or delete them while everybody else can read them. Oh, but we also want the editors or the admins to be able to have this specific access as well. Right? So it gets quite complex. And this will only continue to grow. So the way that I decided to attack all of these complex things is, with an analogy, all right? So bear with me through the threads here. And really, I think this analogy is good because the people in this room and people building mobile and web apps really are at the edge of security and your controls, right? There's no endpoint further than the device itself. So we have Alice here, and she wants to get into this castle. And inside this castle is all the great things for the application, right? There's images and videos, some of them just for Alice, some of them for other people. There's lists that she wants to render into her app and even transition and maybe send analytics data under some conditions. So what's the first way that you would do this? What's the naive implementation? Well, we put a guard at the gate, right? And we have this guard at the gate, and the guard, to prove who Alice is, does the simplistic thing. I write down Alice's information along with her password, password with an @ sign as everybody uses, right, in this ledger. And whenever Alice wants to get in, she sends this information over to the guard. Now, there's a couple of problems with this, right? The first one is, what if that guard, his sword isn't too sharp, right? And somebody can sneak in underneath and actually get to this ledger. That's pretty compromised, right? So you have a vulnerability there. The other thing is, even if you can protect that really well, what about this big arrow, right? This represents the network, and somebody's listening pretty closely. And a lot of these attackers out there are pretty clever, right? They can, deduce from the traffic that's going on what Alice's password would have been even before she got over on the right-hand side. Or even worse, some of our network protocols occasionally get flaws, right? We see this all the time on the internet where it impacts the entire network. So what do we do in this case? Right, so in Amazon world, what we do is we have a user directory is essentially what I've just described here, called Cognito User Pools. We support other stuff as well, like Auth0 and some other partners. But we have a certain technique that we've employed in this, right? So this user directory vends what are known as JWT tokens. And I'll talk about this in a minute. But we put in place what's known as a password authenticated key exchange protocol called SRP. This will maybe be, I was about to say this will be the deepest I go into mathematics in this presentation, but one of the two deepest, all right? So how does this work if I want to stop those problems? Well, the first thing I do is I pick some really big prime number, all right? Call this n. And I say that it's got a primitive root g. Now what that means basically, if you've ever done any algebraic theory in groups, basically means if you look at, I'll use a simplistic case like wall clock time, a modular kind of list of integers. It means that I can pick a specific prime number so that if I keep on multiplying and exponentiating that primitive root, I generate everything in there, right? So this is my sufficient condition. And then I take the user's password and the salt, as well as their identity, and I create a variable called v. This v represents the password verifier. And the key about this, what we've done here is I don't ever actually send the password over the network. It never actually physically leaves the device. And what gets stored in the back end is a verifier. And I don't even need to send the initial generator over the network either. I basically can use some clever mathematics here to just multiply that by a number and kind of transition fields to one vector space to another. And I independently on the client and the back end kind of craft this password verifier that I know. So I have two things that I've accomplished. One, I didn't store any of the passwords in the back end. The second, I didn't risk anybody sniffing the network and kind of deducing the password from that. Now, this is pretty cool. Something to know about, though, since we are at React Europe, is just-in-time compilation does not exist in React Native. And if you want to do some large prime number mathematics like we do in these techniques here and really secure your apps, you're going to have some native bridges to do this, right? So if you use some of the Amazon tools, we provide this out of the box. If not, you're going to have to investigate these techniques, especially when you have kind of these JavaScript style platforms that transition between browsers that can do these efficient computations and then kind of client spaces. All right, so that's an interesting kind of problem that we have there. But if we went around every single site and we kept, even if we implemented this super strong way of protecting usernames and passwords in the network, the customers still need to remember their password everywhere, right? I go to this kind of site and I order some clothes. I go to another one and I order some food. And now I'm putting this problem everywhere to where people then write it down at home what their password is. What's another way to deal with this? Well, it's kind of like if I go to a party, right? Do I always know everybody at the door? No. I say I know a guy, right? And that's essentially another technique is, I have my Facebook account, I have my Google Plus account, I have my Log On with Amazon account. And now Alice just sends to the knight, says, I know this knight over here with the little red hat on. And he's like, yep, I know Alice, let her in. This is what federation and OAuth are essentially, if you've ever kind of conceptually wondered why we have these things. And the way that we do this again, extend that diagram that I had before, is we basically do a series of redirects. It's fundamentally the way that this works, so that the person validating the identity is this third party. So many people wonder about this, like I mentioned a couple terms earlier, OAuth and OIDC. They're related, but not the same thing. So OAuth fundamentally is that diagram that I showed before. I'm outsourcing the identity of someone to this third party, the person that knows my friend so that I can get into this party. And it's just an authorization framework. It has nothing to do with actually authenticating. Authenticating is done by that third party. But it's a series of redirects, right? In the browser and on React Native, it is still redirects, but it gets a little tricky. I'll talk about in a second. And the OIDC layer, which you usually hear are the JWT tokens that are vended out, those are essentially a standard that the major difference comes down to, it gives a user identity, which is in this thing called an ID token. So you have these three fundamental tokens, basically, that this redirect process vends out to your clients, right? So even going, like already I've just talked about this, you can see it's much more complex than kind of, what I talked about in the beginning of just simple passing tokens, right? I have an identity token that proves who I am. I have an access token that proves what I have access to. And the common technique is these expire after 1 hour, because if somebody does compromise a device or the network or something else, you don't want them to forever have access. And the way that we give good UX to our customers in these different flows is we also vend a refresh token. And these refresh tokens are long-lived. And sometimes they're like an hour, sometimes they're 24 hours, sometimes they're longer. But the fundamental idea is rather than storing these credentials on the devices and everything else, they get these tokens. If they want to keep logging in, then you pass the refresh token and kind of get new tokens sent to you. And this is another one of these things to be aware of because you as app developers on the edge have to make a trade-off of good UX for your customers as well as defense and depth. Sometimes it makes sense for everybody to log in once an hour. Many times it really doesn't, especially if you have some other invalidation controls on the back end. All right, so what does this flow look like, this redirect process? So you have an endpoint that usually, according to the OAuth spec, says authorize. And I want to log on, let's say, with Amazon. Now, you can just pass them normally if you have standard ones like the Amazon ones, a provider as a variable. So I pass my provider to say Amazon, but it could have been Facebook or Google Plus or even your own custom one. And it redirects, does that authentication, and it comes back. But the key is the authorization server generated a code. In this short-term code, you're going to notice this is a very common trick when it comes to a bunch of these auth-then and auth-c flows. It's ephemeral. So it's only available for usually 30 seconds up to like a few minutes. And it comes back to the client, and they've passed the authentication flow. Now then when they want to get those tokens, they then hit the token endpoint with the response from that third party as well as this code. And the server cached it for a short time, so it says, yes, the session's valid. I'm going to give this back to the client. Now, similar to some of the stuff I was mentioning before, this is all great in the web. You can see everybody knows about redirects, right? You're building React apps. The common mistake that I find in React Native world with this is people develop, even they hand roll their own flows, and they test it in their emulator, everything's working great, and they get rejected from the App Store. So the reason is twofold. One is because app stores require a strong user agent that's trusted. So in browsers, it's going to be something like Safari, it's going to be something like Chrome, Firefox. But that web browser in React Native, and even on native platforms, is not trusted. So iOS gives you view controllers that you can inherit from, and it looks like a web browser, but it's actually a trusted user agent. So you have SF Safari view controller. Newer versions, you require AS web authentication session. It's essentially Apple's way of giving you finer grained control of what you're authorizing. And then on Android, you need something with Chrome or with custom tabs, actually, which happen to be implemented in Chrome, but you can do them in other browsers too. So that's interesting, but you might say, well, okay, we have this flow, but there's a couple of flaws to this, like what happens if like somebody compromises a little piece of the device? Or as I'll show in a second, what happens if they publish like a rogue app to the App Store? Because if I'm redirecting to that third party and coming back, somebody could like decompile my app and see what it's made of and like try to impersonate it. So there's a couple of other protections that we do here. One is we introduce a client-side opaque state. So very simple. Client, when it does this redirect, sends this string, comes back, and the server returns it. And the client says, if this was the thing that I originally generated, everything's great. So you usually store this in memory on React Native. You store it in something like local storage or session storage on web. Now, as I mentioned before, though, people can intercept this if you're on a native-style application like React Native. So what was introduced in native apps, and now you should be doing in React Native apps as well, is introducing something known as proof of key exchange. This is shortened to PIXE, is what people usually call it. And this is a pretty cool flow. It's an interesting technique. You actually generate you create you use a pseudo random number generator on the client and create like a 120-bit length private key and run the hash of it. And then when you go through this code grant flow, you send it to the server and it sends you back the code as before. But the trick here is, for that short-term session, the server actually stores that hash on the back end. And then you actually send that private key along with the code back to the server. And it does a comparison for you. If those match, because it ran the hash independently itself on the back end, then it sends you your tokens. And so this is what allows you to avoid people intercepting your app and then, kind of compromising by publishing rogue things to the App Store. Okay, so believe it or not, that was just authenticating users. I haven't even now proved that all of my requests that I'm sending over and over are valid. So how do I do this? Well, there's two mechanisms. One is by looking at tokens, and one is essentially doing a hash-based signing. So we're going to talk about these. Now, the first is, and I promise this will be the last time I talk about interview-style questions, but just a little reminder, encryption, right? This is using someone's public key. I write a message, and only they can read it. Signing is using my private key. I write a message, and you can validate it's authentic. And this is important because usually people look at JWTs and they open them up with a text editor and they're like, oh, why can I see this? It's because it's signed, it's not encrypted. You can choose to do that with other tools, but the whole key here is that when you're trying to validate requests that are sent back and forth, you just want to use someone's public key, the server that generated the tokens, to make sure that request is authentic. Okay? So what do these tokens look like? I mentioned the three types, but they basically have three pieces. It's a big string with two periods separating the three pieces. The first part is the actual signature that was used to do that signing. Then you have the payload itself. This has all the meat, all the data that you want to it, right? It's got that username. It might also have logical groups like editors and things like that, depending on your server vending tokens. It also has other attributes that maybe you've been authorized for, like the phone number or the email address. And then the signature at the end. And what happens is, let's look at the right-hand side of this first, is the client just sends, this is the sending in the authorization header, right? This is what everybody talks about. We're halfway through this presentation. And the server then can just do quick validation. And it's very efficient, right? Because usually it's in memory. Worst case scenario, they haven't cached the public key. They have to reach out over the network. But then they can return results. And the natural question we also get from a lot of customers is, well, that's cool, but can I just use session-based stuff and store it on the back end because I want to do some custom thing? And you could, but first of all, it's not scalable because as your app takes off, which hopefully it is as you're building it, it's going to fall over very quickly on the left-hand side strategy. The other thing is, I would assert it's less secure because first of all, people don't even need to go through that authentication phase. They could just start DDoSing the server on the left. And the server on the left has to get things in a cookie, decode it, then it has to look either on the file system or in some database what the user matches to and things like that. And then it can return a response. And what did I just talk about there? Well, I kind of talked about state. And anybody in the React ecosystem is usually familiar. State management is a tricky problem. And now we're talking about distributed state between the client and the backend. So what ends up happening in these scenarios is people think that they built a robust system, but they have some race condition or something else that's introduced. And people have actually logged in. However, now they're trying to just send requests, but they're getting some sort of inconsistent state and they're getting denied access, which is a really bad user experience, especially as your app starts to scale out. So the second type of authorization that you see commonly in cloud providers, and this is really where a lot of people get tripped up, is HMAC-based authorization. So this is very simple. In theory, it's not an industry standard yet is the thing. And what you do is you basically run a 4-part HMAC across the credentials that the client has, a SHA-256 HMAC, in fact, the time, the service, and the region that you're trying to access. And this is what we call AWS Signature version 4. It is a signature. And the benefits of why people usually start adopting these things, especially if you work with enterprise companies that you're building apps for, is because one, because it's scoped by time, you're more resilient to replay attacks. You also are scoping by different regions and services, so you now have a smaller blast radius, even if something is compromised. The other thing is it's more performant, right? And since the service owns its resource, it just needs to do a Boolean check, as opposed to cracking open a JWT token and writing if-then-then statements and checking databases. Now, the way that this works is you get authenticated from a user directory, exchange these credentials to another part of Cognito we call identity pools, but honestly, anybody could just use an STS endpoint if they wanted to do this. And the trick here is that they get three things. They get the user credentials, an access key and a secret key, but they also get a token. And those keys cannot be used without that token. So what happens is the clients run this four-part HMAC and canonicalize the request. And then they send this over the network along with this token. And now, going back to the earlier discussion, even if somebody did sniff that traffic and saw this request, there's interesting talks which you can see online at like reInvent and other things. You could probably brute force this or use like dictionary attacks and other things. But the time to complete a brute force, even if you have supercomputers and through like, several $100,000 of the problem, usually are weeks, right? Which first of all, people can't actually, afford that much to do on just one request over the network. But secondly, by the time that you actually cracked this vector, the tokens would refresh and it'd be a brand new signature, so you'd be starting over. So this is how you get essentially the mathematical certainty that your requests are secured when you're doing authorization. All right, getting into a couple of other things. When you're using cloud providers, that mechanism of kind of associating the resources gives you a couple of other interesting caveats. I mentioned at the beginning you have public and private access, and not so much always on React Native or native apps, but especially on web apps, it's quite common. I go to a website, right, because it's the web, and I want to be able to just read some blog articles, but not comment on them or view the videos until I've signed in. And that's usually guest access. But then once I've logged in, I want to start scoping things down to that individual user so only they can read and write to their data, essentially in a bucket, which is a folder. And those HMAC processes, since they have the client credentials and we're essentially using the identity to validate the user, we embed those into our policies on the cloud services so that your policy doesn't need to actually check each individual user and then match it up to a folder directory. You essentially just use an alias with the user subject, which is a variable that corresponds to their identity, and that's what gives them access to read and write to a bucket. So that's one interesting technique on here. Now the last one, which I think is very unique and not talked about enough, is the use case of I only want my friends to see my data if they come from some friendly village, right? But this is a nice analogy, but what does this really mean? Well, maybe I only want people to see my blog posts or my photos on my social media account if they happen to be friends with me, right? And these patterns show up over and over, like only editors can do this or comments on a blog. And if you start to look at this, it starts to look like a graph, right? And really where I'm going with this is not only are UX flows graph-based, but this is where GraphQL has benefits that are not talked about greatly in the industry yet. Everybody talks about co-location of data and views. Everybody talks about network fetching requests, but you actually get fine-grained access controls by implementing GraphQL in your applications. So let me talk about a very common use case that comes up, right? So I want only friends to see my data. And in AppSync, we do some other stuff too that you could add in like Apollo Server and other things with like pipelining requests. But if you just use a graph model, you could actually have a top-level resolver that hits one data source and returns data like, Nadia logged into her app and she's friends with Shaggy. So it's embedded essentially. These are our dog names, by the way, if you're wondering where I got them. She's friends with Shaggy. So in the resolver context, if you're familiar with GraphQL, you actually get the response from the first table. I would call this authorization metadata. There's a reason I'm bringing up that term. I'll mention it more in a second. And then in the second, the actual data fetcher resolver that runs, because it's been passed from a top level down, it has enough information to do a conditional check whether it should get the response from that other database or not. So GraphQL actually gives you a great pattern that you don't traditionally have with REST to do some of these fine-grained authorizations. Now, to kind of like go towards the end here, I've talked about this castle, and many people say like, CRUD-based apps, these are really simple, right? But if you just take a CRUD app or even, a CRUDL app with like list, is it really simple if you start thinking about your use cases around authorization, right? All of these things like group ownership, public read access, and we need some way to simplify this. So how do we do this? And when we were looking at these problems and working backwards over the past couple years in Amplify, we went back to the way that authorization fundamentally works. And I don't know if you've ever thought about this, but it's an interesting exercise. All authorization and all resources, whether you're talking about databases, you're talking about cloud providers, you're talking about file systems, they all come back to essentially this access control matrix that this computer scientist named Butler Lampson came up with in the 70s. And what it effectively says is that to get access to a resource, it is the intersection of that resource itself, the asset, as well as a user or group that has permissions to it. So if you think about now what I've gone through the past 30 minutes with, JWTs have some access information around the resource itself, or if you pass information to a database, it can run some checks. This is essentially how you can do some of these controls at scale. And the way that taking that graph pattern along with essentially this sort of foundational computer science controls, we created a technique to embed this into your GraphQL data modeling. So we use, at Amazon, we use SDL first, and I'll just briefly at the end talk about how we do this, but we use SDL first to generate GraphQL backends. By default, we generate, AppSync, the managed service that we have, but the cool thing about this is it's open source, and it's just code generation with CloudFormation, so you could fundamentally change some of the implementations if you wanted to. But by taking those techniques around where authorization metadata lives and embedding it in your data model, you can effectively now do very simple rules like just allow this owner to have access to this resource. Just allow the owner and the editors on certain fields to have access to resource. Even dynamic group access or restricting things on a subfield in an object itself. And you can also chain together different objects such as I was talking about like the comments on blog posts. So I'd encourage you to look at some things like this in the future if you want to start doing fine-grained access controls rather than hand-rolling it. And the takeaway from this is all of these things that I've talked about, we build these into our client framework. So if you're not familiar, I'd encourage you to check it out. AWS Amplify is an open source framework for mobile and web developers. It's truly open source. The way that we operate is we have full-time staff working on GitHub issues as well as on-call for these things. But implementations have AWS underneath the covers, as well as some other providers that have contributed to the project. We give declarative ways of interacting like an auth category, as well as escape hatches if you want to do some extra things. And as far as the topics that I've talked about here, we give you JavaScript libraries on some of these things, right? So some of them are JavaScript libraries for React, Angular, other frameworks. We also give you JavaScript libraries for React Native, including some of those native bridges like I talked about earlier to just kind of a one-liner, implement these inside of your apps. And then we do all of that orchestration underneath the covers, as well as the CLI toolchain with a GraphQL transformer that does that data modeling with fine-grained access. So there's 3 key ways that you can implement these in your app. Standardize the configuration, right? In Amplify, we have a CLI, just Amplify add auth from the command line, Amplify add API. A declarative API for building this into your app itself. We also provide some HOCs and stuff like that. We have some open source stuff with hooks as well. But you just call sign up, sign in, federated sign in, and it'll do all of that orchestration, even the social provider mechanisms under the covers. And then the auth modeling like I showed in that annotation. So to wrap up, basically what I was trying to get across in this talk is authorization, authentication. It's honestly not as simple as you think. You're actually at the edge here, right, by securing apps on the edge without any protections between you and the back end. And because of that, these client environments are entrusted. So I'd encourage you to understand how it works under the covers, which I hope I kind of did a little bit of an intro to that here. And also, if you're getting started or you want to integrate some of this in your environment, whether it's AWS tools or others, play it really safe with some battle-tested, hardened stuff. And then if you need to do custom stuff, then kind of escape out of it. Thanks.